Today we're going to be continuing on warm up 411 on this same sheet. We're going to be doing problem numbers 6 through 9, going through and answering these questions. One of them applies to the chapter that we are doing right now, the one you're taking a test on Friday. So we need to make sure that you have, that's tomorrow, isn't it? So we need to make sure that you are prepared for this. So when you take a look at this, you're going to see that right here it says, judging by appearance, it is reasonable to say that the figures below are similar. How do you know? Guys, first of all, these are the same shape. They've got the same number of little triangles going around it. It's got the same circle in the middle. They're equally spaced the way they are here. This one just happens to be a smaller version of this one over here. What they're asking you to do is tell them what happens to that figure. Okay, what is it that actually happens? So it says, yes, they're similar. The figures are similar because the similarity transformation that maps one figure to and onto the other figure. The similarity transformation is first a rotation. So look, this triangle faces up, so it would have to spin some to make the triangle face to the right some. So that is true. It would have to rotate. So it is at first a rotation. Then it's a translation, so it's going to slide. So once they rotate it, they slide it over. And then it is a dilation because they make it smaller. So all that's true. So that may be it. Let's take a look. That one is a possibility. The next one says no, even though they appear similar, there's no composition or transformation that will map it from one to the other. That's not true. It is similar. That means we could also eliminate D too because they are similar. Let's go to C then. C is going to be yes, the figures are similar because similarity transformation that maps one figure to the other. The similarity transformation is a rotation, so they do spin it. And then a dilation, that would just be making it smaller, but it would still be sitting right on top of the other one, guys. Unless you slide it over, it is not going to be a translation to move it over that way. So all this would do would put a circle basically inside here with the triangles shifted a little bit. It would not take care of actually sliding it over. So the choice that you have to go with is A. That's the one that works. C does not work because it does not have the translation as part of it. Okay. This is the way you're going to have to answer questions on the EOC. You have to go through and read all of the words very carefully. Okay, now someone was asking me when we did the vocab about geometric mean. This is a geometric mean problem right here. This is the floaters. Remember, whenever you have a right triangle, you're going to have an altitude drawn in the middle of it. You get 3 similar triangles. If you put the right end up in the air, that means the ones that are floating are going to repeat as your geometric mean. So you're going to have these problems that you can set up. We're going to go ahead and set them up so that we can deal with this. First of all, if this whole thing down here is 14 and this side of it is 8, how much is left for this side over here? 6. That's the first thing you need. Now we're going to set up 3 proportions. These 3 proportions are all the geometric mean proportions. We're going to do the first one for X. X repeats in those spots, and it repeats between the one that touches it, which is going to be 6, and the whole thing, which is 14. Alright. Do the Y in the middle. The Y in the middle is going to repeat in those 2 spots. What does the Y touch? What's on either side of the Y? 6 and 8. So it's the 2 on either side of it. So the 6 and the 8. For the Z over here, the Z touches what? Well, first of all, the Z repeats, put the Z in the repeat spot. What does the Z repeat between? What touches it on that side? 8 and the whole thing. The 6 never touches it, the whole thing. So 8 and 14. So now that you've got that, it says find X, if necessary, round to the nearest tenth. So the one that you're going to set up for X is going to be this one right here. Which one of these is it? Let's take a look and see where we can find it. Well, first of all, guys, look at the first one. It's got 8 and 6. That's not going to be it. Okay. The next one has 8 and 14. That's not going to be it. The next one has 8 and 14. That's not going to be it. And the last one has 6 and 14. That's going to be it. Do you see they just switched where the X's were, but it's still the same proportion? It's the same thing. It's just backwards. but it's got the 6 and the 14. You know that's going to be your answer, but to confirm that it's your answer, you need to show your work and get to the 9.2. To do that, to solve any one of these, you're going to cross multiply. So it's going to be x times x, which is x squared. And what's 6 times 14, guys? 84, thank you. And then when you take the square root of 84, x is equal to, I assume it's going to be 9.2, but check it on the calculator. Yes? It's it has to round to that, but it's that. Okay. And you're going to see that on the EOC. Their answers are definitely going to be rounded answers a lot of the time. So please understand they will do that. And they didn't tell you anything about rounding. They didn't tell you anything about what place to round to, but they gave you a rounded answer. So use your answers as context clues. Okay, guys. So the bottom, let's go down here. So for this one, it says find the surface area and volume of a sphere with a radius of this. Guys, we haven't done this. We may or may not get to it. It just depends. Before the EOC, I'm going to give you the formula, and let's go through and talk about it. For this one, it's going to be 4 pi r squared. 4 pi r squared. That is going to be the surface area of a sphere. 4 pi r squared. It takes four circles to cover up the outside of a sphere. If you took the circle that makes up the middle, like if you split the circle in half, and that circle that's right there in the middle, it's called the great circle. If you take it, it takes 4 of those to cover the outside of that sphere. So in this case, it'd be 4 times, do they have pi in their answer? No. So times 3.14 times the radius, which in this case, does that say 0.8?
Yeah.
It is 0.8? Wow, that's tiny. 0.8 squared. Okay, guys, grab your calculators. Our choices are 7.8, 8.4, 8.0, and 8.2. We're supposed to round to the nearest 10. Which one is it?
8.0.
8.0?
Yeah.
Okay. It's unusual to round to 8.0, so that's it. My guess is that means our choice is C, but we are going to do the other one just in case. 1, because we need the formula. 2, because it doesn't hurt to make sure that we did the first one correct. So the volume formula for that sphere is going to be 4/3 pi r cubed. 4/3 pi r cubed. That's one of those generic formulas. Remember I told you on the formula sheet? This is one of the formulas on there. If you remember, hey, wait, that sphere, that formula for volume of sphere is on the formula sheet. This is one of them. Okay, so it'd be 4/3 times 3.14 times 0.8 to the 3rd power. You have to use that power button. That's that button that says y to the x. Have to use that. So it's going to be 4/3 times 3. Oh, wait. We already set it up. Tell me what it is when you multiply it. I'm hoping it's 2.1.
Yeah.
It is. There we go. That just confirms that we have the right answer, and C is our answer choice. Alright, but again, you need to have down all that work. That 2.06? No, 2.6? Okay, type it again. Clear it out. It'd be 4 fraction button 3 times 3.14 times 0.8 power button 3. You know where the power button is? It's right under the off key. Right under the off key.
Oh,
Power button, the y to the x, yes. And then 3, and then equals.
okay.
Got it that time? Thank you. Good. Anybody else? Good deal. Thank you for saying something, not just sitting there. Guys, these are the kind of questions you gotta ask me. Using that calculator is everything. Okay, last one today says a rhombus has 10-inch sides. 2 of them meet to form a, oh, trig, guys, come on. Or 30, 60, 90 special right triangles, probably. So let's draw this shape. I'm going to try to draw a rhombus. It's not going to be great, but we'll deal with it. Okay, here's approximately a rhombus. Okay. It says it has 10-inch sides, so all the sides are 10 inches because the rhombus has all sides the same. And it says 2 of which meet to form a 30-degree angle. So we're going to have these meet, and they are going to form a 30-degree angle in this corner. It says find the area of the rhombus. Hint, use a special right triangle to find the height. So if this is the height right here, this is going to be a 30, 60, 90 triangle with a hypotenuse of 10. This is not hard math though, guys. You can do this part pretty easily. I just need you to know the magic number. Do you remember what the magic number is on a 30, 60, 90 to go from the hypotenuse to the short leg?
Divide by 2.
Divide by 2. Very good. So 10 divided by 2 is going to put you at 5. And that gives you your height. Guys, from there it's easy. Guys, a rhombus is also a what? What shape is this other than a rhombus? Not a triangle, the outside shape. This is really important that you know this, guys. A rhombus is just a fancy parallelogram. It just happens to have all the sides the same. The area formula for a parallelogram is area equals base times height. So in this case, the area equals, what's the base of that shape? 10, and the height we just found at 5. That's it. So the area would be equal to 50 inches squared. Is that one of our choices? Yeah, B. There we go. Nicely done, guys. That's important for you to know that a rhombus is just a fancy parallelogram. That's all it is. Just has all the sides the same, but all the other stuff is the same. Okay, guys, that's your warm-up for today. Go ahead and put that in your folders, and then we need to get you ready for your test. We are going to cover that review